Welcome back. In this lecture, let's see about conditional distribution and density functions. Before this, let us recall the conditional probability mean that applying the probability on the conditional event. We know that it is the probability of A intersection B by probability of B, where probability of B is not equals to 0. Right. So let us extend this concept on CDF and PDF, cumulative distribution function on cumulative distribution function and probability density function. So let us see conditional CDF, conditional distribution function. See, it is capital Fx of x given B. According to CDF, it is the probability of the event x less than or equal to small x, and here the conditional is given B. Here A is the event x less than or equal to small x. Let us apply the general formula probability of A given B equals to probability of A intersection B by probability of B. So we can write the conditional CDF or conditional distribution function capital Fx of x given B as probability of x less than or equal to small x intersection B by probability of B, where probability of B is not equals to 0, and this is a joint event. This is joint event. Let us see the properties. Properties of conditional distribution function. These properties are same as the properties of CDF. The CDF, we know that at minus infinity is 0. For conditional distribution also 0. It's an impossible event. The event x less than or equal to minus infinity is impossible event, so the CDF at minus infinity given B is also 0. The second one, conditional distribution at plus infinity given B is equals to 1. Here x less than or equal to plus infinity, this covers entire sample space. So the probability of the sample space is equals to 1. And the third property, the CDF or the conditional distribution function is bounded by 0 and 1. And we know that the CDF plot is staircase. This is x and this is CDF. The CDF plot is staircase like this. This is x1 and this is x2, where x1 less than x2. It is monotonically increasing. It is increasing function, not monotonically. It is increasing function. Sometimes it is monotonic, sometimes it is not monotonic, but it is increasing function. Okay, so from this we can say that the CDF at x2, the CDF at x2 is greater than the CDF at x1. From this plot we can see that. So we can write conditional distribution of x1 given b is always less than or equals to conditional distribution of x2 given b if x1 less than or equals to x2. And fifth one, probability of x1 less than x less than or equal to x2. So this can be written as the conditional distribution of x2 given b minus conditional distribution of x1 given b. And other property is conditional distribution of x plus given b is equals to conditional distribution of x given b. This is right continuous, or fx of x minus given b is equals to fx of x given b. So these are right continuous. The first one is right continuous, the second one is left continuous at x. So these are the properties of conditional distribution. Now let us see conditional density function. This conditional density function can be represented with small fx of x given b. This is the representation. We know that the PDF probability density function can be obtained by derivating cumulative distribution function CDF. The same thing we have to apply here. Small fx of x given b is equals to d by dx of conditional distribution capital Fx of x given b. This way we have to obtain the conditional density function. Let us see the properties. So the first property is the PDF is always non-negative, whether it is a conditional or not conditional PDF. Fx of x given b is greater than or equals to 0, meaning that non-negative. The density function is non-negative. The second one, area under PDF. Here the PDF is conditional PDF is equals to 1. And the third one, we can obtain the conditional distribution from the conditional density function by integrating from minus infinity to x. Here the conditional density function is f of u given b du. So CDF can be obtained by integrating the PDF. And the fourth one, probability between x1 less than x less than or equal to x2 given b. So it is the integration from lower limit x1 to upper limit x2. We have to integrate the conditional density function small fx of x given b dx. So these are the properties of conditional density function. Thank you.